So this will become relevant at that point. All right, so Markov. M is the division symbol. A is the math key. R is the multiplication symbol. K, open parentheses. O is the 7. And V is the 6. I did kind of cheat and Google something because what I wanted to do is create a loop. So because what this is a recursive operation, Markov chains. So you use outcome. It's an iterative process. So you use the outcome from one trial as the starting point for the next trial, and that result gives the starting point for the next trial, and so on. And so I wanted to create a loop. So apparently the way to do that is to just label a starting point. So in program, so select program. I got to refresh my memory. It's in here somewhere. Program under control is option 9. And you come up with a placeholder. I used A, alpha math. So when I do my go-to operation later on, that's where I'm going to go to. So it's program option 9 to get label, and then alpha math to get the A. Now what I wanted to do is a simple calculation, and that's just matrix A times matrix B, and then I want to store the results in matrix C. So second matrix, the way you would get matrix A. Yeah, those are. It doesn't matter what it is because we would only operate this program after you've inputted matrix A and B. What's that? You do the store key. It's right above on. Right. So the way I reasoned it out was if I put something in matrix A and then multiply it by whatever I put in matrix B, store the result in matrix C, that will happen behind the scenes. Then I could go into matrix C and see the answer if I want. I don't know that you need a program to do simple matrix multiplication, so that's not really the point behind it. What I would want to do is display, so regular program, input output option 3 is display. So again, that's program IO option 3 brings up display. Hit program, then over to IO, then option 3. I'm going to select matrix C. Right, because the calculator will store it, but it'll do it behind the scenes. It won't present you with the answer. I think it would be just lovely if it also, aside from doing the work, presented us with the answer. And also, I'd like it to be in fraction form. I don't want funky decimals if I can avoid it. I'd rather write fractions down. So math, enter, enter. So we would display matrix C in fraction form. And then what I would do is store matrix C back into matrix B for my second loop so that I can actually just point back to the operation of A times B gives C. So I'm going to do second matrix option 3, store second matrix option B, or so option 2, which is matrix B. All right, then program. I don't remember where pause is. I believe it's in the control menu. Yeah. So program, in the default menu control, go to option 8. That'll pause the program, because before it goes to the next iteration, I want to stop and look around. I want to see what the answer is for that first iteration. right? And so then I'll pause, and then to undo, when you run the program, to undo the pause or to unpause, you just hit enter, and it takes you to the next part of the process. And then go to A. So program, somewhere in the control menu, let's go to, there it is, option 0, alpha math. And that's your program. Very straightforward, simple, minimal operations. But what it saves us from having to do is, because you know anything about iterations, you take a result from one thing, you got to run it through the process again, take note of what the answer is, then run that answer through the process again, take note of what that answer is. Here, if it's actually going to do all that work for us behind the scenes, that's even better. So I'll just test it out real quick. Um, I'll put in some matrix A. We'll do a 2 by 2. Let's say it's 3, 1, 5, 2. I don't know. And then some matrix B that can be multiplied by matrix A. So you still got to know your dimensions. So 2 by something. I'll do 2 by 1. Keep it simple. Let's say it's a decimal value 0.7, 0.3. I don't know. Bless you. So we have a matrix, and we have the weights associated with that matrix. So those are in there, and now what I can do is run the program, Markov. Gives me my first calculation. You see the rapid blinking nonsense up in the upper right-hand corner? That's indicating the calculator's paused. Right, so it's paused in the program, so to unpause and enter, it gives me the second iteration, third iteration, fourth, fifth, and you can keep going. You know, this one I just made it up, so I wouldn't expect it to converge on anything, but you can go hundreds of trials through. The idea behind the Markov chain, when we actually do an example, would be that it's going to converge on a particular vector. And so if you keep going, eventually it locks into what the true, we call it a steady state vector would be. Right? So a little precursor of what's about to come.